And hello, everyone. Welcome to the first episode in a series from Shift Technology. This is the Agentic Insurer. This is episode 1, which is the shift from automation to autonomy. And today I have Eric Sibony from Paris, France, joining us. Eric, how are you doing?
Hi, how are you?
I'm good.
I'm a bit hot. It's hot in here.
I hear that. I think you'll feel better once France wins the next round of the World Cup.
Yeah,
Likely.
they will, of course.
Okay. So Eric, we're going to start all of these episodes by allowing our guests to do a little bit of an elevator pitch. Eric, who are you and what do you do?
So I'm one of the co-founders of Shift, and I'm Chief Product Officer. My background is actually in math. I did a PhD in math, and we started Shift with my co-founder right after college. So I don't actually have much more any other real experience. We had a short time at AXA Group. That's well known. That's our story. That's how we came to know about insurance and insurance fraud. Insurance fraud was our starting point. So at Shift we build and provide AI solutions for insurance, and of course we've now integrated agentic AI in all our products, and this is clearly the next phase for the evolution.
Absolutely. So I want to sort of start this conversation, Eric, by talking about automation. I don't think automation is a foreign language to insurance companies. Insurance organizations in general. I think there's been a lot of work to try to automate. Can you talk a little bit about automation and what process, as you have been developing Shift, what have you seen as processes that have been automated? And then we can kind of take it from to the next step. What types of things have insurance organizations been automating?
So I'd say I think insurers have tried to automate many things, usually with success, but also usually with limitations. I have maybe an analogy for automation versus autonomy is when you look at transportation. So when you think automation typically applies to an automated subway or an automated train. I don't think you have a lot of subways in the US. I know you take a lot of car, but in Paris we have a certain number of subways which are completely automated. But it's not really sophisticated, and it's been there for probably 1 or 2 decades now. In the sense that it goes just goes straight, right? So automation is really about does the train moves forward or does it stop? So very, very simple. Automation in that sense is really like it's a predefined set of actions, and it's a matter of making sure that the system works well. Autonomy, on the other hand, is the word used typically for autonomous vehicles, and there it's completely different, because when you ask a vehicle to go from a point A to a point B, an autonomous vehicle, it will face so many situations, so many unexpected events, that it's not just about like a fixed. It's not just a fixed trajectory, right? So many things can happen. And that's the reality. The complexity that comes with automation is that it is really being able to react to anything that can happen from the real world. And so if you apply that to insurance and, for example, claims processing, the automation approach to claims processing is by predefining some usually simple claims that has simple predefined trajectories, and it's about making sure that then the processing goes well on this trajectory. But it's doable. It's been, I think, insurers have done it for the last let's say 5 to 10 years, but then it hits a limit, because claims in reality that can fit in that predefined trajectory are the minority. The vast majority of claims are just like, there's so many things that can happen, and automation falls short. And this is where you need to get to autonomy to be able to process them, to have more, to have your system process more of them with accuracy.
Can I repeat that back to you in my own translated language because I think this might help the audience because I really like that metaphor. So automation is using the train analogy. It's either moving forward or it's standing still, and it has to stay on its set of tracks. So it knows what stops it has to go to, when it has to go to them, but it is a really simple set of directions that it can then begin to execute. Whereas autonomy would be the train could go forward, stop, potentially backwards, but potentially could then make decisions on switching tracks and finding the more optimal set of solutions. That a little bit more enhanced definition of automation.
Yeah, you can see it like this. I think at this point the metaphor with the train gets harder. But if you take a car, an autonomous car, then it's clear, right? If you really ask the car to go from point A to point B, there's so many things that can happen. Someone crossing the road where they shouldn't, some accident, some road that is now closed whereas it was supposed to be open from the GPS. Like there's so many things that were not expected, and so the autonomous car is able to react to all of this.
So, Eric, for the autonomy, that also means that the system needs to learning, keep getting better, right?
So, yeah, I would say it's most likely true for a first phase. So, by comparison, as a human, before you can drive a car, you need to learn how to drive. Now, once you know how to drive, at some point, you're good to go. You don't need to always become better at driving. I guess most of us don't, unless you're a professional driver, right? And that's the thing we want, right? If we want autonomous vehicles, we want them to drive well. We don't need them to drive perfectly. So you need learning to get there, because the other alternative to learning is some system that is fully predefined with many rules, and we know that technically it doesn't work. So learning is key in the first, but then once it's there, I would say somehow we can stop learning. In reality, we'll always, kind of maintain. You need always to maintain your learning in a way, but it's not in order to get better. It's more to maintain your level.
Yeah. So let's talk about from automation to autonomy. I think a simple question. In order to create autonomy, must you have automation first?
It's a good question. I wouldn't say so. It's well, you can, and it would make sense, but no, I would not say it's necessary. I think so. Both are change, both are a transformation. For insurers, let's say 20 years ago, all insurers were doing everything manually. That's for sure. Over the last 20 years, there's been more and more, some kind of small automated processes, and it has accelerated over the last years. But so it is a transformation, and I think the key point, the key difference between the two, is how you build trust in the system. And the trust is a bit different whether you go for automation versus you go for autonomy, because automation, like I said, is much simpler. So somehow it's simpler to build trust, and also it goes with I would say a more traditional testing way, a more traditional way to test things. Whereas autonomy, by definition, you need to trust that the system will react to the unexpected. So you cannot test everything. So there's other approaches and methodology to build that trust. And so the first one can help the other, but you can also directly go to building autonomy without going to automation.
Yeah, I think about in the 1980s, early 1990s, when China was building their infrastructure, they were able to skip landlines and basically go direct to mobile, right, and just build an entire mobile infrastructure. And my question, Eric, centers around I think the vast majority of insurance organizations that have not probably done the significant work to automate, right? So it could be due to tech stack, it could be to culture, but now they're looking to make the shift to something that's more autonomous. And they may be wondering as well, like, do I need to go through that step? But it sounds like the same kind of Chinese metaphor where you can skip over the landline, just go right to mobile and build that infrastructure. You don't have to do the in-between steps. That's what I think I'm hearing you say.
Yeah, and to give also maybe a concrete example, one could think that you need it because of the data. Because what's true is that once you start automating, then by design you should collect a lot of structured data about your process, because you've defined an automated process. By comparison with when humans do it, sometimes they will miss some things, or mostly when humans process claims, typically a lot of the content will be recorded as nodes, as free text, unstructured data. So when you have automation, then you have some structured data. So you could assume, could be intuitive, that if you have this structured data, then it's better for autonomy. Now the thing is, and that's mostly due to modern AI. Since modern AI, I prefer to call it that way. So let's say modern AI, starting with ChatGPT back in November 2022, and then the LLMs, the agents. We're now in a situation where unstructured data is not a problem anymore. So if as an insurer you didn't go for automation or didn't invest a lot in it, you may have a lot of unstructured data. That's not a problem. AI can now leverage unstructured data in a very effective way, in the same way as it can leverage structured data, of course. But I mean, you see the gap is really, really small.
Yeah. So let's create a framework here for how an organization can get to autonomy. What do you think? How do you see around, from an infrastructure standpoint, what needs to kind of exist, or what does an organization have to start putting into place to create a foundation to create autonomy?
So there's a first part of the answer I would say is about the target state. So the target state, when you have a system that can process autonomously, you need to have in place some integration, the right architecture, I would say, to do that. I don't want to enter too many details there. I also don't think it's necessarily the biggest challenge. There's probably, if you look at the technical details, there's a lot of different solutions. But if you step back overall, at some point, you have your system that is being let's say you have your core system where you manage, let's say, your claims, your policies, whatever, which has the data in there. And then you need this autonomous processing system. It needs to access the data, it needs to process, it needs to send back data, it needs to send back instructions. So overall, the architecture, I would say, is not that complex, except for the subtleties. I would say maybe not the trickiest part, but where it gets a bit more complex is how you get there, how you get to the target state, and it really ties to the part around building trust that I was mentioning. Our view is that to get there, you need to have the human in the loop, and by the human, not any human, precisely the ones who are, let's say, processing claims today. And so to do that, but when I say in the loop, means that you need to have them make sure that your system that provides autonomous processing is performing well. And the best way to do that is by integrating, the outputs of that autonomous system directly in their UI, so that they can work directly with it, and that indirectly from what they do, then you can then prove that the system can be trusted. I'll give you a very, very precise example. So we've defined different levels of autonomy at Shift, and the switch to get to autonomy in our levels is level 4. But to get there, we go first through level 3, and level 3 is where the handlers, let's say, have the system pre-create everything for them, so that when they look at it, they can just see, oh yeah, okay, the system did this and this and this, everything is fine. It even prepared, let's say, the email that it needs to be sent. It wrote everything according, of course, to the templates and rules and so on. And then the handler just has to validate in one click. When you get to that point, then you have the data that shows that the humans really just validated, and therefore it means that the system was correct. So progressively, you can have trust because you have. I mean, it's not just a blind trust; like it's really data-driven trust in the system. And at the same time, the humans also benefit from it because they just need to validate, right? Most of the work is done for them. And when you get to that, then you can prove, you can say, okay, you can be confident about the system, and so you can authorize the system to then act in autonomy. And that's when, in our language, we say you switch from level 3 to level 4 in that case. And then you get to the target state. I mean, but that the phase, the trajectory to get from current situation to target state is, to me, the critical one, and it has to go through this phase. From our perspective, that phase where you have the human handlers overseeing what's happening.
Yeah. So I think of when human handlers, I think of the tasks and workflows, Eric, that I've built in the past around automation, where I would say I spent more than 50% of the time testing. More than 50% of the time, like, okay, I'm building something. I'm going to test it, see if it works. Oh, something broke. Let me go in, fix it, test it again, and just kind of keep doing it. And even when it gets to the end, I'm sort of then retesting it with curveballs, trying to get it off kilter. Like, where might this thing break as well? For modern AI and moving to autonomy, I would think even the human element is still especially critical because there's a higher degree of trust that's required to get to autonomy. And so the amount of testing, you're likely to spend significantly more time testing and evaluating versus building. Does that fit what you see?
Yeah, and it fits also the methodology I was describing, because indeed, with this approach, it's kind of we keep the testing work in a way, but we combine it with a usage in production. The idea behind this methodology is that because you want to be able to face the unexpected, the only way to test the unexpected is by really having it work in production. So during this phase that we call it systematic human control, then every situation is processed by the system, let's say by the AI agents in particular, in the background, and then it pushes it to the human, and so it's as if it was a test, as if there was, let's say, like an intern doing almost everything, and then just the person validate. But it's still a concept of testing, and it's critically important because the first thing, as you said, like, we don't know everything that we cannot expect. But once you've done it on 1,000, 10,000 situations, at some point, okay, well, you can still have something that maybe you didn't encounter, right, on this 10,000, but then it means the probability of it encountering in the future will still be really, really small. So once you have a big volume, that's the way to make sure that you've covered, what can happen in reality. And also the other source of unknown is how you've driven the system, because now with agentic AI in general, it's very easy to ask agents, let's say, to do anything, and you can give them documentation, you can give them the law, you can give them, for example, in insurance, you can give them, general insurance conditions, so the policy wordings that contain, what's covered, what's not covered, how it should be covered. You can give them standard operating procedures, so the documents that contain the ways the claim handlers process. Mm-hmm. You can get all of that to an agent, and the agent will use it to process. But the key question that remains is, how can you be sure that it does what it's supposed to do? How can you be sure that it will interpret every document exactly in each situation? Either because maybe the agent will fail, or actually most likely because some of the documents will have some ambiguity, because we're humans, and even our law has some gray areas. We know that in every country, law is never fully precise. That's why you have lawyers, right? So because of all of this, you need to make sure that the guidance you've given to the agent, and also facing all the unexpected events from the real world, in the end, everything still holds and works.
Yeah. In case, anyone in the audience, this is episode 1, so without jumping too far ahead, we do have episodes where we will be talking about more of the agents and the agentic AI. Eric, can you give like a brief definition of what is an agent and what is agentic AI? Because we live in insurance, so when I hear agent, I'm immediately thinking of like a broker as well. For modern AI, for the audience, define agent and agentic AI.
Yes, sure. I should have said AI agent, by the way. So I will assume everyone knows, ChatGPT from November 2022. That was the big revolution, and then it was an LLM, and there's others, right? I'm citing ChatGPT, but there's the other players, and so actually, to me, the best explanation of what it is when you look at time. It's going back in history. So 2023, all of these were LLMs, which at the beginning were only looking at text. Then it was extended to images, but still LLMs. The key first evolution that came was back in 2024, was when the various companies launched what they call the reasoning models. So what they added to LLMs is the ability to reason facing a problem. The first LLMs were just answering a question without, let's say, thinking about it. Sometimes it was good, sometimes it was bad. So that's what they did. And then in the year 2025, they've added tools so that so that the LLM, let's say, can think, but can also use tools. And then when you combine the three, an LLM that can think, that can reason, and that can use tools, that's what becomes an agent. But what interestingly is that if you look at ChatGPT today, using GPT-5 now, or 5 point something, it is an agent. So everyone now using, and there's hundreds of millions of people using ChatGPT today, they are all using agents, let's say, without knowing it. But you can see it, because when you ask a question to ChatGPT, you can see that it's thinking, it's showing you that it's thinking, depending, of course, on the complexity of the question. And like an obvious example is web search. Before, in the past, when ChatGPT came out, it was known that it had learned on the internet up to a certain date. So anything that had happened since then was not known. And if you asked something about that, then it didn't know. This does not happen anymore, because now if you ask ChatGPT something about like something that should be found on the internet, firstly, it will reason and it will identify that it should look on the internet for that. And then it will use a tool or several tools to go find that on the internet. And that's how, by combining tools and reasoning, then it will provide a much better answer today than it did at the beginning. And so in terms of use cases, these agents, then the first use case is exactly the same as the first modern AI. So like just answering questions. But then also, because they can use tools, they can also use tools that will trigger things. And so now you can also even ask it to perform actions. So for example, you can ask it, please find me, the best flight ticket to go to this destination with these criteria. That's the first step. And then you can even ask it, now I want you to buy it. So I would say is my kind of a short answer for what an agent is.
Yeah. So we've defined that, and we'll sort of begin to end this particular episode with I'd like to get finalized with autonomy, and we've been hinting at like what that looks like. I understand that Shift has an acronym, ARISE, which kind of details some of the stepwise levels of moving from automation to autonomy. Can you define ARISE and kind of go through each of the acronym letters?
Yes. That's indeed the framework I was referring to with level 3 and 4. So I will define it more properly. So it's ARISE, 5 letters for 5 levels of autonomy. So the first one is A, stands for answers. So level 1. It's kind of the same use case I was just describing. In this level, the AI agent, is just answering questions. To be more specific, for insurance, it would be answering questions to a handler, like a claim handler, an underwriting handler. Because if you answer a question already to the client, that's already there is a big autonomy there. So answering a question to a handler. So typically, like I said, like a chatbot use case. Now the thing is, on claims, for instance, you don't want the claim handler to ask questions to the AI every time, because they would ask the same questions on every claim. Also, sometimes on some claims, maybe they won't know what question to ask. So that's why you need to get to at least level 2, which is R for recommends, where there the AI will recommend what to look at or recommend what to do, the best next steps, by analyzing all the data. So in this level, the AI is following some goals and some problem that it's given, and then it's providing that. Then the level 3 that I was alluding to before is called initiates. And in this level, as I was describing, the AI will prepare everything. So it goes beyond just saying you should do this as the best next steps, but not only you should do it, but I'm preparing the work for you. So you only have to click, like I said with this example of sending an email or triggering a payment. It will it will pre-calculate all the parameters to trigger the payment. That's level 3. Then level 4 is S, that stands for solves. So in this situation, the AI agent will solve the problem autonomously. And that's where it processes in autonomy, meaning that there's no human intervention. And it doesn't mean it's necessarily end-to-end. I mean, it can be end-to-end, or it can be, I would say, just for one small task, one small step of the workflow. But what's important is that it's autonomous. And to get there, as I was saying, the key point, there is, of course, technical challenge, but mostly there is a trust. How do you prove that you can get there? And that's why we always say to get there, you need 99% accuracy. So you need to show that the system is, performing at 99% of by comparison with the rules that it should be applying. And then we've defined level 5. Level 5 with E stands for exceeds. So level 5 is where the AI agent is better than 99% accurate. So it's looking at it differently. Is what if the rules and the processes that it's applying are not always optimal? That's kind of mimicking the best senior handlers. They know that sometimes in some unique situations, the standard operating procedure falls short or is not the best thing to do. And so they will take the initiative to deviate from it in order to get to the best outcomes. That's level 5, when the AI agent is able to do that in autonomy. It may sound like science fiction today, but honestly, I think technically we're really not far from being there. The challenge, I would say, on top of level 4 is how to prove it. I mean, there's additional methodology, again, to prove trust, that indeed the agent is so good at what it does that you can allow it to deviate from the standard rules.
Yeah. So, I mean, E sounds like wisdom, right? It gets really wise. So, Eric, I'd like to end episode 1 by discussing, in the past, Eric, as technologies have sort of rolled through, it was kind of prudent for insurance organizations to follow, right? Let someone else take the risk. There was almost no penalty, right? Like the internet came and you saw insurance organizations really take their time creating their own website, even using email and things like that. There was very little penalty for not rolling into the cloud, for instance. What you're describing, though, sounds like there is a penalty, that if you do not move, as organizations kind of go through the Arise model, their advancement will accelerate, right? I can actually envision a world where you build AI agents that check on other AI agents, making sure that they're doing the work. And so companies can actually accelerate growth or their ambition at scale without necessarily having to continuously, linearly hire more people or more staff around that. In your opinion, do you see that organizations that adopt modern AI and agentic AI will have a leading advantage versus organizations that do not?
Of course. There is no other answer. And that's true everywhere. So, I mean, to me, modern AI is not a bubble. It is a revolution, as many have said, but it's not just I don't want to be hype. It's just like fundamentally what it does, it brings, a way to automate thinking. Thinking so far was really just for humans, and now not anymore. And a lot of what people do in a lot of jobs is thinking. So naturally, when you start having an AI that can do that, then it raises a lot of questions. But even more for insurance.
And so, Eric, I feel like we're at a stage now where there's a penalty if you are not adopting these technologies. Whereas in the past, Eric, with the internet, social media, mobile technologies, cloud technologies, it might have been fairly prudent for an insurance organization to allow the dust to settle and see, let someone else take the risk. And there was no major penalty for that. It feels like with this technology, if you're not adapting to it, those that do will get such a substantial lead, it'll be difficult to kind of catch up. What are your thoughts around the need or almost the requirement to shift to agentic AI and modern AI technologies?
Yeah, I think it's a must. I'm of course not the only one to say it, and it's not specific to insurance. But what happened with modern AI is not just a new thing. It's not just a hype. It's a fundamental revolution. It's new technology, but it's for the first time technology that is able to replicate human thinking at the same level. When we talk about autonomy, it's where it goes, right? And that's a huge change because so far we were the only ones to to be able to think facing a problem and find a solution and solve it, more or less complex, by the way, the problem. And now we're not. Now AI can do it. And beyond the philosophical question, which is not what I want to talk about here, from an economic perspective, it fundamentally changes the thing. Where you needed before humans to do the work, you don't. Where you needed to always, let's say, hire more to do more, now you don't.
And so, Eric, that's a fantastic way to end episode 1 in moving from automation to autonomy. And so, for the audience, this is episode 1 of a 6-episode series. My name is Nick Lamparelli. For my guest, Eric Sibony, thank you. And wait for episode 2, which will be right around the corner. Thank you.